Right, now on to the 2023 array of records. So this has got the kind of normal 2 marks, 2 marks, and then it's got a big 7 marker. Now, first of all, I think that panic last year's class when they came out of the exam afterwards and they were going, oh no, there was a 7 mark question. But actually, when they then talked about it, they seemed to know what they were doing with it. The way to think about something like that is it's an opportunity for you to get lots and lots of marks. It's not meant to be incredibly complicated and impossible for you to ever get. Actually, there's more chance of you getting some of the marks than if something is maybe quite a short 3 and 4 mark question. That's the way to look at it, right? So it's opportunities for you to get marks. I really like it because I think it's got a lot of problem solving in it. So we've got this shop that sells a range of 80 different washing machines, and we've got sample data about it. We've got a brand, reference number, important there, it says number. If you look at the data, it's actually got letters in it. It's probably a bit of a tricky mark in there to make sure that you're actually looking at sample data. The maximum wash load in kilograms, that's an integer. Spin speed, that's an integer. The price, that's a real number. And the number in stock, and that's an integer. So straight into defining the array of records, or first of all defining the record structure, and then move to declare the array. The record structure should be called feature, so that's interesting, it's given us a specific name that we have to use. So I'm in Python, and I'm going to implement it as a data class. So what? Data class feature. So I'm using that name. And then I've got each of my attributes. So we have the brand, which is a string. Reference number, which is also a string because it's got letters in it as well as numbers. The maximum load, which I'm just going to call load for simplicity. That's an integer. The spin speed, so I'm just going to call that spin. That's an integer. The price, that's a real number, which means we'll implement it as a float. And the number in stock, so stock, and that'll be an integer. Right, then we have a short data flow question, but it's only worth a couple of marks. It's a relatively simple data flow. So customers often ask questions about the washing machines. For example, how much is the cheapest washing machine that can do a wash load of 11 kilograms or more and a spin speed of 1500 or more? Top level design is shown below, so we're reading the data from a text file, and that's actually already done for us if we look at it. So we've got nothing going in, and what's been passed out there is this machines. Now it's one array instead of parallel arrays there because it's the array of records. Then step 2, ask them to enter the smallest wash load and the slowest spin speed required. So that's like their criteria here, the smallest wash and the slowest spin speed. Find the price of the cheapest washing machines if there is one that meets the entered criteria. Now I'm just going to switch to highlighter. When it says the entered criteria, that's the smallest wash load and the slowest spin speed that they are willing to put up with, if you like. So when it says the criteria, that's what it's getting at. Step 3 is the one that we have to do. So find the price of the cheapest washing machines. Now to get the price, I'm going to need the machines array. So machines, and that's brackets because it's an array, and then it says that meets the criteria. Well, these are the criteria, so smallest wash, slowest spin, and I'm just going to annotate these for future reference because I'm going to try and give you this PDF afterwards. So just quickly link in those. This is where it's coming from. Then last thing in there is for step 4, we need what's going in. So step 4 is display the price of the cheapest washing machine that meets the enter criteria. That bit about meets the criteria, we've already done that in step 3, so it's a little bit of a red herring. We don't need to pass the criteria in again. Or a message that says no washing machine meets criteria. Well, again, we're not going to do that as part of the data flow because that's input and output to the user. It's not what's part of the data flow. We need the price of the cheapest washing machine that meets criteria. That is cheapest price. And we need to know whether or not one was found, so that found variable. So in actual fact it's the same as what is coming out of the step above it. That's not automatic. We know that because, again, if I highlight it, let's highlight that a different colour. So price of the cheapest washing machine that meets the enter criteria, that's cheapest price. So that's where we're getting that from. I'm not just doing it because it's the one that was above it. And then we got onto the 7 marker, which is the code question. And like I say, although this is 7 marks, and I think when people did this, when they came out the exam last year, they were all in a bit of a panic about it and going, oh no, there was a 7 marker, that was a big question and we didn't know how to do it. But then they told me about it and actually they did know what they were doing. The way to think about it is there's actually more marks on offer for doing something that you would have done anyway that might have been a 5 or 6 mark question. There's more opportunities for you to get the marks. So I see this as a good thing if they keep this sort of question up. And I like it because there's quite a bit of problem solving to it. So it means that even if you don't get everything, you'll get some of them. So step 3 finds the cheapest or the price of the cheapest washing machine that meet the enter criteria. If there's not a washing machine, then found is set to false. So I'm just gonna underline that. We have this variable found that's going to be a true or a false. Using a programming language of your choice, write code for step 3. Your answer should use the data structure. So that's machines. That's this machines array. And then we're going to have the dot notation. So machines something dot price or dot stock or dot spin or whatever it is. The criteria, if we look at the page before, the criteria were the slowest spin and the smallest wash. So that's how I know what the criteria are. So it's finding the cheapest. Last thing I'm going to kind of annotate for now. You see how this is different in 2019? So that is going to be a find minimum. Now in the 2019 one, like we said, that actually used the word maximum. This one didn't. It said the cheapest. So you might see something like the cheapest or the fastest or the slowest or the longest or whatever it is. And they're trying to maybe avoid using the words that would give away whether it's minimum or maximum, so you're having to do a bit of thinking there yourself. Right, first thing I'm going to do then for a find minimum algorithm, and I'm going to leave myself a little bit of space in case I change my mind later and I want to initialise another variable. First thing I'm going to do for now is set the minimum. So call it minimum, or I could in fact just to keep it call it cheapest price, because then it's the same as the data flow. So cheapest price equals. Now if I set that to the very first price in the list, that would look something like machines 0 dot price. But that's wrong because I don't know if that meets the criteria. So instead, underneath I'm going to rewrite it. I'm going to say that the cheapest price is something that's quite a high value that we know that none of them are going to be. So essentially, I'm using a ridiculous value here. So if I said the cheapest price was something like 99999, we know that nobody's spending 100 grand on a washing machine, presumably. So whatever we find is likely to be underneath that, and it's a slightly hacky way of doing it, but it's all right. And in the real world, that's possibly the way that people would actually do this, although there's a more correct way that we could do it. We could have a second loop and we could go through it and we could find one that actually meets the criteria, but this would do. Then we're going to loop through all the washing machines. So for, let's say, I in range 80, because I know that there are 80 washing machines in the array. I know that from the earlier question. I want to say if, first of all, if the machines I dot price is less than the cheapest price, because there's no point in continuing if it's more expensive anyway. So if that is less than the cheapest price and it meets the criteria, so and the machines I dot spin is at least as much as the slowest spin, because that was a variable that was passed in on the data flow, and so it's a very long condition here. Machines I dot load is well, at least as much, so that's going to be the same condition as the minimum load that they wanted, so that was the smallest load or smallest wash. So great big long if statement. If it meets all of those three conditions, then we want to update that. So I want to set cheapest price equals machines I dot price. And also I want to say that I found it, because if I look back at the top of the question, we had this thing about whether it was set found false. Now, if I find one that doesn't meet the criteria, I don't want to have an else set found false, because that would mean that found starts off as true. We want to go into this from the presumption that we haven't found one, and we're only going to change that to true if we do find a match. And the reason for that as well is, say I find a match on the first one, and then I go and look at the second one on the list and it doesn't, and I say found to false, effectively I'm forgetting that I already found one. So I want to say found equals true. And to do that, for it to start off as false, then I need to have another variable, or rather another line with the same variable that says found equals false, so that it starts off false and it's only changed if we get something that meets the criteria. Now I just want to double check that I've done everything in there, because it was a 7 marker and quite a long question. It doesn't do any harm to go back through it and almost like a checklist to yourself think, have I done all the things here? So I've done my found, and I'm going to tick it off. Obviously you wouldn't do that in your actual exam, but I can do that. So I've initialised the cheapest price with a sensible value. I've got the found starting off as false and then being updated later. I'm looping, although there isn't actually a mark sometimes in a question like this for looping, because you might have 2 or 3 questions that are sort of similar in the paper, and you might find that one of them has the mark for doing a loop, but that the other two then don't, because that would be a bit samey and it'd be a bit easy at higher if you were getting a mark just for doing a loop when that's a National 5 concept. If the machine's I.price is less than the cheapest price, so that is the first thing I'm checking. Is it cheaper? If it is, I'm updating it, so I'm updating the cheapest. I'm saying does it meet the criteria? So yes, it does. So I've got the criteria. So I've got 1, 2, 3, 4, 5, and I'm using my array of records. So I'm using machines, which gets me the mark, and I'm using the dot notation with the correct attributes, like this. So that gets me a mark as well. And I'm just going to write on there, correct attributes from earlier. So yes, it is a longer question. It's going to take you a little while to do, but there's lots of opportunities in there to get marks that even if you didn't get absolutely every part of it right, you should be getting some of them. You should certainly be getting these syntax things for getting your dot notation and using the same array name that they gave you earlier.